Okay, in this video I'm going to be describing as concisely as I can the functioning of the starting and choke circuit in the 36 DCD carburetor. It's quite a precise and interesting design. It's not as simple as you may think. So it could be a bit of a long video, and I'm making this as much for myself as I am for other people. I may not even publish this because it took me a while to figure out how it all works, and I don't want to have to do that again years from now because I tend to forget these things. So if you're only watching this video to know what goes in this hole, these are the parts that go in that hole. The reason I say this is that a lot of times what goes in that hole is missing, like they are in this carburetor. And the reason they're missing is that these little crimps give way and the spring pops the plunger out and all these pieces fall out, and this one can fall out from the bottom when you take the cover off. So if you're only here to know what these are and what the effects of them missing are, I'm going to tell you right now. You don't have to watch the whole video. These pieces are the start enrichment circuit. They control the start enrichment circuit. So it's not the choke, it's not the cold running circuit, it's a starting circuit. So what they do is they give the engine a big shot of fuel from a reservoir, a separate reservoir of fuel, when the engine is cranking only. That's what the purpose of all this stuff is. So the engine will run just fine without them. The choke circuit will still work, but you won't get the enrichment starting without these pieces. Now, if you're missing this piece, which is the bottom piece, you will have a giant vacuum leak and a lot of whistling coming out of this hole. So keep that in mind. Okay, if that's all you wanted to know, you can leave now, and you can either run the car with these or without them. All right, getting on to the description of how those pieces work in the whole circuit is actually quite interesting. So taking the cover off, you will see that this is the fuel reservoir. And the starting circuit starts on this side. These two parts are where the fuel comes from. So this is, underneath here is an emulsion tube and a jet, just like your regular emulsion tubes and jet, a little different design. And that controls the choke enrichment, you know, how rich the choke is. Under here is a cylindrical reservoir full of fuel, or as full as the fuel bowl is of fuel. And the purpose of the cylindrical reservoir is to feed the circuit when the engine is cranking and the choke has been pulled. So if your engine's hot and cranking and your choke is off, this does not come into play. Everything is off. When your engine is cold and you've pulled the choke all the way, what happens is this reservoir of fuel is emptied into past the choke circuit directly, and it's very rich. It hasn't been leaned out, as you'll see a little bit later on, how it gets leaned out once the engine starts. Also, the fuel in the height of the emulsion tube is also dumped into the start circuit while the engine is cranking only. And all of that fuel comes up through this hole right here. It goes up and over through a passage and down through that hole. So all of the fuel that feeds the choke and starting circuit goes down through this hole. This is a plug that holds in the plunger, and there's a spring under there that holds the plunger down. So basically, as an overview, how the circuit works is that this pulls up a plunger, which allows fuel and air to mix and go down past the throttle plates and enrich your circuit. As you reduce it, it actually adds air in through a pretty complex little series of holes that start to lean out the circuit. And we're going to look at that next. Okay, I think it's a lot easier to visualize how the starting system works by looking at the diagram here. And to orient you, this is the bore. There's the butterfly. Over here is where the choke cable attaches. This is the top plate. And further away, this is the fuel in the fuel bowl. And these are the two parts of the starting circuit that are in the fuel bowl that I showed you already. That's the emulsion tube and the air corrector, and then that's that other little brass plug, and this is the reservoir for the start circuit. I've colored the moving parts here, which are little brass plungers. So that's the upper brass plunger, and that's the lower brass plunger right there. And this is the passageway, which is exposed to vacuum, which goes below the throttle plate. And that's the little hole. Well, we'll get to that in a minute. Okay, so the first thing that happens when you pull the choke is it raises this piston here, exposing this entire channel passageway to these two channels. One is air, that's where the air comes in, and the other one is the fuel channel right there that goes up here, and it goes across down to here. So what happens is when the engine is cranking, there's not enough vacuum to pull this upper piston down. This upper piston stays up when the engine is cranking. And there's a vacuum hole right there which connects up into it. And once the engine is running, it'll pull that piston down. But so the condition currently is that this piston is up, the choke has been pulled, and the engine is cranking. So what happens under that condition is fuel starts coming up. It gets sucked up, and it's very rich fuel. There's not a lot of air in it. And it comes across. Actually, there's these are connected. It comes across to this channel and down. Passes all of this stuff, and it enters the airstream right here and continues down. So this is the cranking just while it's cranking. Now just while it's cranking, air comes in here, and I'm coloring air green. This is the cranking air. And you get the idea. It mixes in, and you get pretty much just a dump of fuel. So just when it's cranking, it sucks all the fuel out of this reservoir. It sucks all this red out and dumps it into the starting circuit. It empties this depending on how long it's been cranking. Once the engine starts, there's enough vacuum from that hole. It goes through there into this little plug and pulls down on this piston. So once the engine starts, we're in this condition where this piston has gone down, and you can see it's lower. And the effects of that are that it exposes this passageway right here. So now air is allowed to go down through here. and it mixes with the fuel before it even gets to here. So going back to this, let's just imagine that this piston is down. Now we have air coming in. So it's essentially weakened the mixture. So the engine's now running. We've got two sources of air coming in. And this is all air up here. It's all coming in. Now the engine's starting to get warmed up, and you want to start closing the throttle. So you start lowering this piston. You'll notice that when this piston is all the way up, there's a passageway over here which connects. So even when that piston is down, when this piston is down, this is the running condition. I should probably write that in there. But do that running there. When this piston is down and the engine is running, these are blocked off, right? Those are blocked off, those passageways. But when you start lowering this piston, they start becoming exposed to air. And the air starts coming down here, and it actually goes across. There's two passageways. So as you start to slowly lower the piston, it starts exposing more and more of the passageways, and eventually the piston will be all the way down, and it's exposing even more air. So it's leaning out the mixture as you reduce the choke, in addition to starting to close off this hole. So it's doing two things as the choke gets lowered. The hole is getting closed off, and it's putting more air in. Eventually the choke is all the way closed. So this is the no choke. No choke. This is the choke all the way closed. This passageway is completely shut off to vacuum. So no fuel is being sucked out of the fuel bowls, and no air is going down through any of these passageways. It's completely stopped. Now, sort of an interesting thing is that even though this big passageway has been shut off, the small vacuum signal right there is still acting on this piston. So this piston presumably goes up and down with varying vacuum. As the engine runs, it's always going up and down, presumably. I haven't seen that in person, but I'll look for it now. Yeah. So an interesting observation is that if you try to start the engine and it doesn't start, it sucks all this fuel into the engine, and that's it. It's gone. But then I think if you wait a little while, it's going to refill this reservoir, and then if you try to start it again, it's going to suck that fuel in again, which could make your engine, flood. So I think you'd have to, if it doesn't start immediately, that's sort of like a problem, of course. The other thing is that if you open your throttle butterfly while you're cranking and it's cold and it hasn't started yet, you're essentially stopping or reducing significantly the vacuum signal through this passageway, and you're not going to get this fuel coming up through here. That's really important. So you shouldn't even crack this butterfly when you're trying to start the engine. Now, if you're missing this piston, like a lot of the cars are, as I noted at the very beginning, if you're missing this piston, you don't get any enrichment from this circuit, the dump of all this stuff while the engine is cranking. What you get is just the regular choke. You get whatever the regular choke gives you, which is not as rich. So you get all this air coming in through here with the fuel. So you get a less rich mixture. And I've noticed that in my car because I've been running it, mixing this. Okay, let's go take a look at the components in actual real life, and you can see where all this stuff is. Okay, now that we understand how the circuit works, let's take a look at the components and the location of all of these in a little bit more detail so you can orient yourself with your carburetor. So here in the float bowl, this is where the fuel comes from the float bowl. It goes across the passageway and it comes down into the choke circuit right here. This is the top plate, by the way, as it's pretty obvious. This is the vacuum signal for the upper plunger, and this is where that plug goes in, which I'm going to show you in some detail. That holds the plunger in on the bottom. This is the plug. It's like a vacuum, the vacuum signal plug. So the vacuum goes through or sucks through these holes in the side and is connected to the center. And then there's a spring and the plunger go over that, like that. It's a very weak spring, actually. So it looks like that. And as the vacuum sucks on it, it pulls that plunger down. That's the upper gold-colored plunger. And on top of that, there's a bushing on top that holds that in. And there's a little spring clip. Right here is where the air feeds. That goes right there. That's where all the air for the entire choke circuit feeds in and to mix down below with the fuel. So that's the upper plate components. And now looking at the choke plunger itself, focus on that. There's the choke plunger, and it lifts up when you pull the cable like that. And when it lifts up, it covers those two holes. Those two holes, as you recall, are the leaning out holes. So as you start to go off the choke, it uncovers those holes slowly, and it adds more air to the fuel mixture, leaning it out. At the same time it's leaning it out, it's also closing the plunger, closes the hole down there. And right here is where all the air comes in to feed the main air feed, I should say. This is like a secondary air feed, leaning out air feed. And then it mixes back in there and goes around this plunger down underneath. I do focus on the depth there. It goes underneath, and there you can see the plunger. There you can see the plunger right there, the brass. It's not quite focused. There. You can see the brass plunger in there, and you can also see this hole, which is the vacuum for the start circuit. You can see that's the vacuum hole for the start circuit. So that's pretty important. Your top gasket is actually pretty important because it seals that vacuum hole off. So then all of the air-fuel mixture kind of like pass on the other sides of the throttle plates. So something to note is when you're starting the car, if you push on the throttle, you'll lose the vacuum signal, and then your little your start circuit won't be as rich as it should be. You shouldn't push on the throttle at all when you're starting. Okay, so those are all of the components of the system, and this is just an old DCD carburetor that I have. Well, they're all old, aren't they? But this one I'm just not using at the moment. It's incomplete. Those are all of the components of the system, and hopefully you understand exactly how it works. It took me a little while to figure that all out, so that's why I decided to make this video, and also so I can remember how it all works. I can just watch it again. I hope you enjoyed the video, and if I've made any mistakes in my assumptions of how things are functioning, leave a comment down below. But please consider your comments carefully, because I do read all of them and make sure that they're accurate. All right, signing off. Thanks for watching.